question. Our next question is, given a number n, find a pair of prime numbers whose sum is equal to n. And then they are giving us some number and then they are showing us how we are going to get the output. So what I will do, I'll actually take you through the scribble and then I will show you how the numbers are going to get generated. So let us say we have n5. So what are all prime numbers which we are going to have before 5, starting from 1? So it is actually going to be 2 and 3. So luckily in this case, we just had two prime numbers and sum of those two prime numbers is actually equal to your given number, correct? So they are actually interested into knowing the pair of prime numbers which can actually give you the sum equal to n. So how you have to do this question? So in this case, you first step which you have to do is generate all numbers, all prime numbers from 1 to n minus 1. After having all the prime numbers, what you just have to do? Check for two values having sum equal to n. That is how you have to find out the sum, correct? So in this case, what we are going to do, if you are familiar with one famous algorithm, that is Sieve-Arrhenius, and that is what we are going to use here. So basically how that algorithm is going to help us here. So that algorithm is actually going to give you all the prime numbers. So let us say you are giving it some number like 9. So it is going to give you all the prime numbers, that is going to be 2, 3, 5 and 7. Correct? So it is going to give you all the prime numbers which are there less than that given number. Alright? And then if you have all the set of prime numbers, what is the basic task is going to be left? You just have to check what two possible numbers are actually giving you sum equal to the given number. So before jumping into the coding part, we'll be going through its algorithm and then we will see how we can actually reach to that decision. So before that, let's discuss the Sieve algorithm first and then only we will be jumping into the second step, that is finding out the sum of two values. All right. So let's discuss Sieve. Correct. In this one, like how this algorithm is actually helpful. So it says that given a number n, print all prime numbers smaller than or equal to the given number n, correct? And also you will have to say that this n, like this algorithm is actually going to work for smaller numbers of n. So if you have extremely bigger value of n, or you are actually trying out for a bigger value, in such a case, this algorithm is not going to work. All right. So now what it is actually going to do, like I'll be showing you the working, but before that, how it is actually going to work. So let us say I am giving you a number 10. So what and all prime numbers are we going to have for the same? 2, 3, 5 and 7. Correct. So this is going to be the output. Now let us say we have another value. Let us say we have n as 20. So what and all prime numbers we are going to have for number 20? It is going to be 2, 3, 5, 7. Then we have 11, 13, 17 and 19. So all the numbers less than this. Even if let us say this is only 19. In such a case, 19 will not be included here because it is going to give the numbers which are going to be lesser than the given number. Alright. In this one, like what we have to say, why are we using this algorithm? Because this is one of the most efficient algorithm which is actually helpful when you have to find out all the prime numbers. All right. And in this case, like I'll be actually showing you with the help of a chart, with the help of one table, that how we are having the values and how this algorithm is going to work out for us. All right. So in this particular one, what we are going to do, we are going to take up one example and let us say I'm taking one bigger example, 50 only. All right. Now with this value 50, I will be showing you how we are going to make this algorithm work for us. All right. So what I will do, I'll be first of all displaying all the numbers up to 50 here. All right. So it is going to be 1, like I'm just writing down all the numbers. Okay. Starting from 1 to 50. So now after writing down all the numbers, correct? What is going to be our first thing? So here we can actually knock off first number, that is 1. Why? Because 1 we do not consider when we are talking about the prime numbers. And here what is the intention of writing down all these numbers? That is because we want to find out all the prime numbers. All right. So what we are going to do in this case, firstly, like I have to write down all the numbers. It's up to you. You want to write it down in a tabular form or something. I thought why to waste our time in drawing out a one tabular form. I just wrote down simply. All right. Now the first thing which you have to do is you have to mark all the numbers which are divisible by 2 because 2 is the first prime number. Correct. So I'm just circling all the numbers. Correct. So we have successfully circled all the numbers which are divisible by 2. After that, what we will be doing now, our second step is going to be just you have to mark those numbers which are divisible by 3 because why we are doing it in that case, if you will observe, 3 is the next unmarked number. Remaining numbers are already marked, right? So we are starting from 2 and then we have to move to the next number, that is 3. So now I'm going to mark down all the numbers which are divisible by 3 and those numbers which 2 has already marked, but now with the 3 also we are going to get like 6 or 12, anything. So those numbers we are not going to mark again, just to have to mark it in the first go. All right. So it is going to be 3, then 9, 12, 15, 18, 21, 27, 30, 33, 39, 45, 48. That's all. Correct? Now, after this, if you will observe, 2 is marked, 3 is marked, 4 is marked. Now we have next number as 5. So what we will be doing, we are going to mark all the numbers which are divisible by 5. So if we are marking through 5, so what we are going to get, 5, 10 is covered, 15, 20 is covered, 25, 30 is covered, 35, 40 is covered, 45 is covered, and then 50. So what we are actually doing in this case, we are getting rid of that particular number and all its multiples. Correct? What we will be doing in this case, we have to keep on doing it unless we are getting rid of all the numbers. And One more thing, like when we started with 2, so in the output you actually have to write down 2, because with 2 we actually started crossing all the multiples of 2. Then we started with all the multiples of 3. Then we started with multiples of 5. Correct? Then we'll have to check against 17. So now let's just, I'll take some other color. Let us say this one. Now we have to mark all the values for 7. Numbers divisible by 7. So just 2 numbers we got. But after this, what you have to do in the output, you have to write down 7 as well here. After this, what is the next number which is left? If you will observe, we have next number is 11. And if you will observe one more thing, multiples are actually getting removed. What are the numbers which are getting remaining? Only the prime numbers. Correct? So now let me take some other color and we'll get rid of all the multiples of 11. So 11 here, then 22, 33, 44. Only these numbers are going to be there. Next one is going to be all the multiples of 13. So first 13, then 26, then 39. So all those numbers are already covered. Then we have 17. So you know what we will do, instead of actually checking against all the numbers, what we will do, we will simply write down. So 11 we did, then we did for 13. If you will observe, we have 17. Then multiple of 17 is 34, which is already covered. So we can write down 17 as well here, right? Then next number which we will be getting is 19. Multiple of second multiple of 19 is 38, which is already covered. Then we have 23. Next multiple of 23 is 46, which is already covered. So we can just write 23 here. Then we have 29. Next multiple of 29 is actually not going to be covered here. So we can write 29. Next multiple, next number 31. Its multiple is not going to be covered. Then we have 37, multiple not going to be covered. Then we have 41, we have 43, 47. That's all. So these are going to be the prime numbers which are going to be less than 50. Let us say out of all these things, I was targeting for a some value, just let us say 30. So what I can do, we can take 11, I can take 19, and I can say if we are going to take these two values, we are going to get a sum which is going to be equal to the given sum. So now what we will be doing, I will be taking you to Visual Studio Code. We are going to write down the algorithm for the same. In this one, like what the algorithm is going to be all about. Firstly, you have to check for all the numbers divisible by 2, then 3, and then so on. And if and how long you have to check? If the given number was 50, you have to check for the one value less than that. Okay, you do not have to check it against uh, all the numbers including that number. All right, it has to be excluding that number. So I'll be getting rid of this code, and let us say we are defining a C function. Here what I will be passing on, I will be passing on one number n on which we will be doing all the testing, and then I'm passing one boolean is prime. So what this is prime is going to do, it's true or false is actually going to tell if the n is actually prime or not. Okay. So here what we'll have to do, so first of all, we'll have to initialize all the entries of the Boolean array as true. So that is required. I will be writing down all the comments so that when I'm writing down the code, you can also get an idea about what and all steps we are going to follow for the same. So initialize all entries of Boolean array as true. And you know, it's we are actually taking is prime. So whatever value of is prime is going to be there, that if that is going to get set to false, what we are going to conclude from there, that the number is not prime. Otherwise, it is going to be prime for the same. All right. So for this is prime. What we are going to do for 0 and 1, we are going to take value as false. So why we are taking these values as false? That is because initially, if we have to check for any number 0, or if we have to check for any number 1, is it anyway going to be prime? Answer is no. So this is prime is actually going to have all the values starting from 0. Why are we taking starting from 0? Like, it's up to you. You can actually skip those values. But if we take any array, it actually takes the indexes starting from 0. That is the prime reason we are setting these two values as false. Otherwise, it was not required. All right. After that, what we will be doing, we are going to have one loop, and that loop is going to start from 2. Why are we starting from 2? The sole reason is we do not want to start from 0, because we already know for 0 and 1 that they are not going to be the prime number. So it's better if we are going to start it from 2, and this n is not going to be included. Why we are not going to include n? That is because we are not concerned about the last value. It is saying that you have to check for all the values less than n, correct? That is why we have taken it like that. So in this, what we are doing here, we are going to assign all the values as true or initially true, because that is what we are going to do. And also this is prime array is going to have values n plus 1. Why? Because it is going to store all the values which is going to be there, right? So that is how we are doing. Now after this, what you will have to do, the next one is going to be, like, I'm doing nothing, but if you are already familiar with the sieve algorithm, so I'm just using the sieve here. So what we do in the sieve, you have to, like, if you actually remember what we were doing, if we had a number 2, we were getting rid of all the values which were multiplied by 2. Also, if you will observe, when we take all the multiples of 2, that also covers all the values which are squares of 2, that is all the numbers divisible by 4. So that one is actually going to get covered when we are going to check for values divisible by 2. So here what we are going to do, in order to actually have an algorithm which is going to be very good in terms of times complexity, so it's always a good approach to actually get rid of a lot of cases. Otherwise, if you are going to run it, like, let us say here number was 50, if a loop is running for 50 times, is it a good approach? No, right? So we can actually get rid of unnecessary iterations, right? So here what we will do, since we are taking it against prime number, so I'm starting it with variable p, and here, like I said, we have to consider it squares as well, so I am doing p into p. All right. Now, what we will have to do here, if your prime number is not changed, what does that mean? If that is not going to get updated, in such a case, it is a prime number, right? What do we mean by updated? That means if it is not marked, if you are marking it false, in such a case, it means it is not a prime number. So if it is not a prime number, what you will, like, you just have to check if that value is going to be true or false. So if it is true, means it is going to be, like, it is something which we are not updating there, correct? So inside this, what we will do, we just have to update all the multiples of this number p. What does it mean? There I actually showed you getting rid of all the multiples of 2, then getting rid of all the multiples of 3, and so on. So this is the same thing which we are trying to achieve here. So just update all multiples of p. When we are updating all the multiples of p, what you will have to do, you again have to run one loop, and this loop is actually going to set the value as false for those ones which are not going to be yet included here. So what does it mean? When I'm taking, let us say, number 2, So that one is actually going to set is prime false for 2, 4, 6, 8, 10, 12 and so on. Correct? So for that particular case, we are going to run our loop. And here it is going to be starting from P. And instead of P, we'll actually start it from P into P because we are considering squares as well, right? And we are going to go till N. After this, what we just have to do, set all the values to false. And in this case, what we will be doing, here we are setting all the values as true or false, right? We are just going to return false from here because if we are reaching here, we'll have to return the value as false because true case is going to happen initially, correct? And this this true and false is actually going to be used at the time when we are going to call this function, okay? So now what we'll have to do, we have to calculate a function which is going to do, which is actually going to find the prime pair. So we can say find prime pair. In this case, what and all we are going to pass, we are just going to pass your value n. And then what it is going to do, it is going to generate all the prime numbers using the sieve algorithm. So we can say generate all primes using sieve algorithm. Okay, so in this case, what you will be doing, you have to use one variable that is prime, and to that you are going to create a array. This array is just going to store the corresponding values, and this one is going to be n plus 1. Then what you will be doing, you are going to take one loop which is going to start from 0 to n. Because we have to consider it for all the values, right? And initially what we are going to do in this case, for this is prime, we are going to set the value to false, correct? Then what you have to do, just you have to call sieve, and to this sieve what you will be passing your value n plus your is prime array. Both of the values you will be passing there. After that, what you will have to do, you have to traverse all the numbers, and when you will be traversing the numbers, you are actually going to find out the pairs, right? So what you are doing, traversing all numbers to find first pair, correct? So what we will be doing in this case, you have to run from I 0 to n. And when we are in this iteration, what you will just have to check, you just have to check if your prime value for that particular case is true, because that is what matters, right? Also, you have to check for its for its previous value. Why are we checking for this n minus 1? That is because we are actually considered about finding two values for that particular pair. That is why we are doing it in this case. After that, what you have to do, you just have to console out two variables, right? So you just have to do, like I'm actually updating the printing out these values, okay? So I'm just making it as space separated. Okay, and once you are able to find out such a pair, what you will have to do, you just have to return from there. Now let us say I am going to call this function. So what I will be doing in this case, to this find prime pair, I am going to pass, let us say 5 only, and let us see what result are we going to get. So this one should actually print 2 and 3. Okay, here it should be P. So you can see with this algorithm, you actually got as 2 and 3. If like you're already aware about this algorithm, you will find this question extremely easy. If you are doing this algorithm for the first time, you may find it little difficult. So what I will advise you, just go through the algorithm once and then you come back to this question and then you try to solve it. It is actually very interesting problem and it is very easy as well. All you have to do is to know how the sieve works, and that I have shown you with the help of one example by taking n as 50. You have to just give it a try on your own and trust me, you will find it super interesting. So I hope I was able to make two questions easy for you. So stay tuned guys in the next class. Bye bye.